The other half of this worksheet, Part 2, talks about revisiting 3.5 applied statistics, reviewing the connector depth data, and then doing some kind of analysis on that data, addressing each. What value did you use to indicate central tendency? Was it population or sample mean? And is there a difference in numerical value between population and standard mean? Well, if we look back at 3.5, and this is not the best looking copy of it, but this is a copy of it. They use this little sigma thing, which means population mean. So back here, we were using population, and there is no numerical difference. And it tells us we use the population standard deviation to indicate the variation in connector depth data. Which value, population or sample, should be used to estimate the variation of the connector depth among all connectors produced? Explain. So let's take a look back at this again. It says here, part of the quality control testing for a toy is to measure the depth of a connector piece that must fit into another part. The design depth is 4.1 centimeters. This is what we're going for. And every 10th part produced on the line is measured. The following data was collected during a 2-minute production period. So all of this represents 120 different parts that were made. Every 10th one was pulled off the line and measured, and they all should be 4.1 even, but there's some that are under and some that are over. So we should have used sample because we pulled every 10th part. Then it says calculate by hand sample standard deviation of the connector depth data. And we can use the data table we made in 3.4, blah, blah, blah. I said you don't have to do this, so let's ignore that. Use the formulas or function in Excel to find mean, median, mode, population standard deviation, and sample standard deviation of the connector depth data. So, and then if you don't have the worksheet, they give it to you right here. 3.8, 3.9, 3.9. So let's go to a spreadsheet, and I'll just open up a new one over here. So I'll put in connector depth data, and what did I say, 3.9, 3.8, 3.9. I got those a little out of order, but they're still the same numbers. 40, 3 4 zeros, 3 4 ones. 4.1, 4.2, 4.3, 4.4. And it says after we have those numbers, use formulas and functions in Excel to find mean, median, mode, population standard deviation, sample standard deviation of the connector depth data. Okay, so we want mean, median, mode, standard deviation of the pop, standard deviation of the sample. Is this it? 1, 2, 3, 4, 5. They want you to find 1, 2, 3, 4, 5 different things. Okay, so this is going to be equal to AV to the average of this data. This is equal to the median of this same data the mode of the data. And for some reason it's not giving me the nice formulas, because here I'm going to have to look one up. I don't know off the top of my head which one to type in for standard, which one to type in for population. Oh, wow. There we go. Okay. So stdev-A is for sample, stdev-P is for population. Entire population versus sample. Let's go back to this. Let's say equals stdev-A for this equals stdev-P for this. Okay, so we got all that. That answers all of that question. It says, come on. How do the statistics presented in Excel compare to the toy connector depth statistics you calculated by hand? So they're asking you, hey, look at this. How does that compare with this other worksheet that you filled out with the mean and the median and the mode and the standard deviation? You tell me. It says create a copy of the histogram using the 2D chart tool and use the following bins. Well, again, if you're using Google, they're not going to let you pick your own bin, so you can highlight the data. You can go insert chart, and you can tell it that it is a histogram, but it's going to pick the bins for you. So this is going to be what your histogram looks like. Oh, and now it lets me move it. Does it appear normally distributed? It should. This definitely does not look like a normal distribution. If you do it with these bins, though, it should make a nice normal curve for you. And the explain your answer part, check back in your notes for what a normal distribution looks like. What makes it look like a bell-shaped curve? There should be three things. It should have a high point in middle. It should decrease on each side, and it should be roughly symmetric. How do you spell symmetric? So then all you have to do is print this out and turn it in. I'll leave you to do the conclusion questions on your own, but hopefully that cleared up a lot of questions on how to use Excel. And look forward to seeing if this helped you out.